Hello students, welcome to Ma'am and Me Academy. I'm your mathematics educator Bipul Babu, and today let us continue the exercise 15.1. Before this, if you haven't seen the first and the second video of this chapter, you should click on the I button here and then check it out. Okay, in the previous video we discussed all the examples related to this exercise. Now let us see the exercise 15.1. Okay, so the very first question is the fill-up, which I think you should do by yourself because it will give you clarity on the chapter. Now let us see the second question, which says, which of the following experiments have equally likely outcome? Now what is this equally likely outcome? Let us first talk of this statement or words, equally likely outcome. Okay, what is this event, equally likely outcome? Let us understand this by an example. Okay, if I throw a coin, then what is the probability of getting a head? It is 50%. You can get either head or tail. That means in this event, getting the head or a tail is half-half. Okay, the chances of getting head or the tail is 50-50%. For example, if I throw a dice, then I can get either 1 or 2 or 3 or 4 or 5 or 6 equal number of times. Okay, so that event is known as equally likely outcome. Now in the second question, they are asking whether the given situation is an equally likely outcome or not. The first situation is a driver attempts to start a car. The car starts or does not start. Whether it is an equally likely outcome? No, it is not an equally likely outcome because the car may start or may not start, but it depends upon certain conditions. What? Whether the car is fine or not, okay, whether it is defective or not, whether the fuel is there or not. Okay, so this is not an equally likely outcome. So the first question, for the first part of this question, it is no. Okay, it is not an equally likely outcome. It depends upon certain factors like fuel, the condition of the car. Okay, now let us see the second option. Second part, a player attempts to shoot a basketball. She or he shoots or misses the shot. See, this is also not an equally likely outcome. Why? Because he or she shoots or misses the shoot. It depends upon the player. If the player is pro, okay, if the player is pro in his game, then he can shoot it, right? And if he is new to the game, then he might miss the shoot. So this is also not an equally likely outcome. Are you getting the meaning of this equally likely outcome? There is the probability of getting the outcomes 50-50% chances, equally percent of chances. Okay, each outcome has an equal percentage of getting in the outcome. Okay, now let us see the third part. A trial is made to answer a true false question. The answer is right or wrong. Now this is an equally likely outcome. Why? Because the answer can be right or wrong. See, each probability, there is an equal probability that it can either be true or false. So the second part was a no, and the third part is yes, it is an equally likely outcome. Now let us see the fourth part. A baby is born and it is a boy or a girl. Of course it is an equally likely outcome because there are only two possibilities, either a boy or a girl. So this is an equally likely outcome. Now let us see the third question. Okay, first to fourth are those type of questions which you can do orally also. Okay, so the third question says, why is tossing a coin considered to be fair way of deciding which team should get the ball at the beginning of a football game? See, why they are asking why we should use the coin. Because while tossing a coin, the probability of getting a head or the probability of getting a tail is same. There will be no biasness in this throwing of a coin. Okay, so you can say that probability of getting a head and probability of getting a tail is equal in throwing a dice. It was equal to 1 upon 2. Okay, we saw in the examples, right? So that is why we throw the coins. So there will be no injustice, or there will be no injustice towards one team. To avoid, you can say that, to avoid injustice or biasness, we use a coin to decide the fate of the game, to avoid injustice or biasness. Why? Because the probability of getting a head or the tail is same or equal. Okay, now in the fourth question it says, which of the following cannot be the probability of an event? So let us first know what cannot be the probability of an event. Let me just rub it for you. Now I already told you in the introductory part that the probability of an event lies between 0 and 1. Okay, that means it can be equal to 0 and greater than 0, but equal to or less than 1. Okay, so let us see the fourth question. In the first part, the probability is given as 2 upon 3. Yes, this is possible because it is positive as well as it is less than 1. Okay, and the second part is minus 1.5. Now you can see that it is negative, and as you know that probability is never negative, so this cannot be the probability of the event. Third is 15%. Okay, so yes, it is possible because it lies between 0 and 1. Okay, that means in terms of percentage it is 0 and 100%. Now the fourth part is 0.7. Clearly it can be seen that it lies between 0 and 1. So this can also be the probability of the event, but minus 1.5 cannot be the probability of that event. Now let us have a look at the fifth question. Fifth question says, if PE, that means probability of an event, is 0.05, then what is the probability of not E? Very simple, you know that formula, right? What was the formula? P of not E is equals to 1 minus P of E. Simple. Okay, so let us substitute the values here. 1 minus 0.05, which is equals to 0.95. Okay, now let us see the sixth question, which says, a bag contains lemon flavored candies only. Okay, lemon flavored candies. In that bag there are lemon flavored candies only. Do notice there it is only. Okay, and Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavor candy? Orange flavored candy. See, as it is told to us that there is only lemon flavored candies in that bag, so how can we draw an orange flavored candy? Is it possible? No. That means the probability of getting an orange flavored candy is 0. Let us see the second part. A lemon flavored candy. Obviously, if you take out one of the candy from the bag, it will be lemon flavored only, because that bag contains only the lemon flavored candies, right? So the probability of getting a lemon flavored candy will be 1. So can you name the event? Yes, it is an impossible event. Very good. It is an impossible event. Now name this event. What is this event known as? Yes, it is a sure event or a certain event. Okay, now let us have a look at the seventh question. Seventh question says, it is given that in the group of 3 students, probability of 2 students not having the same birthday is 0.992. What is the probability that 2 students have the same birthday? Now, is it similar to the question number 5? Yes, indeed. Okay, so I have written on the board that the probability of two students not having the same birthday is 0.992. We need to find the probability of two students having the same birthday. So we can find it by subtracting 0.992 from 1, right? So it will be 0.008. Simple. Now let us see the 8th question. What does it say? A bag contains 3 red balls and 5 black balls. In a bag there are 3 red balls and 5 black balls. Okay, let us read further. A ball is drawn at random from the bag. What is the probability that the ball drawn is first red? So what is the probability of getting a red ball? Very simple. How many red balls are there? 3. And how many total balls are there? 8, right? So 3 upon 8 can be the probability of red ball. Okay, now let us see the second part. Not red. Probability of not red. So what is the probability of not red? That means it can be black ball, right? So it will be 5 upon the total number 8. Is it clear to you? Okay, let us see the 9th question, which says a box contains 5 red marbles. Okay, 5 red marbles. Very good. And then 8 white marbles. Okay, 8 white marbles and 4 green marbles. 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out is red? Now try to solve it. Pause the video and just give the answer. How many red balls are there? Yes, there are 5 red balls. I'm doing it directly, but you have to show it on the copy that total number of red marbles equals to 5. Total number of outcome is equals to 5 plus 8 plus 4. Okay, so is it clear? Okay, now what is the probability of getting a red marble? It is 5 upon the total number of marbles. 5 plus 4, 9, 9 plus 8, 17. So what is the probability of getting a red marble? 5 upon 17. Now let us see the second part. The probability of getting a white marble. White marble. How many white marbles are there? 8. Good. 8 upon total 70. Now in the third part they are asking that probability of getting not green. Probability of getting not green. That means indirectly they are saying that probability of getting red or white. So in all, our favorable outcome would be 5 plus 8 upon the total outcome is 17. Do notice they are not asking about the green marbles. They are asking not green. That means we will count red and the white marbles in this question. So it will be 13 upon 17. Okay, so let us see the 10th question of this exercise. A piggy bank contains 100 50 paise coins. 100 50 paise coins, 50 rupee 1 coins. The total number of 1 rupee coins are 50. 20 2 rupee coins, 20 2 rupee coins, and 10 5 rupee coins. 10 5 rupee coins. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paise coin? What is the probability that it will be a 50 paise coin? So very simple. See how many 50 paise coins are there? 100. And what is the total number of coins? 100 plus 50 plus 20 plus 10. So what will be the total? 150, 170, then 180. On solving you will get 2 5s are 10 and 2 9s are 18. Okay. Now let us see the second part, which says what is the probability that it will not be a 5 rupee coin, not a 5 rupee coin. So it will not be a 5 rupee coin, that means it can either be 50 or 1 or 2, right? So let us add these three: 100 plus 50 plus 20 upon 180. Okay, now let us simplify it: 170 upon 180 or 17 upon 18. Okay, yeah. So I think this is very clear to you. It is the simplest chapter of your syllabus. Now let us have a look at the 11th question as well. The 11th question says, Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from the tank containing 5 male fish and 8 female fish. Now what is the probability that the fish taken out is a male fish? Very simple. First of all, let us write how many male fish are there. There are 5 male fish, okay, and 8 female fish. Alright, and randomly Gopi has taken out a fish out of the tank. So what is the probability that it will be a male fish? So how many male fish are there? 5 out of 13, right? So this will be the probability of getting a male fish out of the tank. Now let us see the 12th question, for which there is a circle given and there are some numbers on it. A game of chance consists of spinning an arrow. Okay, there is an arrow here. We have to spin that, and which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8 as shown on the figure, and these are equally likely outcome. Okay, what is the probability that it will point at 8? What is the probability that it will point at 8? See, you can make the statement by your own. Okay, it is not necessary that whatever I am writing you should write that only. Okay, it depends upon you. Now what is the probability of getting 8 in this game? There is only 1 8, right? There is only 1 8 out of total number 8. Correct? Did you get it? What I am asking, what is the probability of the pointer pointing at 8? How many 8s are there on the board? There is only 1 8. And how many numbers are there? There are total 8, right? 8 numbers. So the probability will be 1 upon 8. Now let us see the second part. This was the first part. Probability of getting an odd number. Probability of getting an odd number. How many odd numbers are there? 1, 2, 3, 4. Total 4 odd numbers are there out of 8 numbers. That means the probability will be 1 upon 2. Okay. Now let's see the third part, which says probability of getting a number greater than 2. Probability of getting a number greater than 2. Pause the video if you have understood the concept behind this question and just solve it sidewise. So how many numbers are there greater than 2? 1, 2, 3, 4, 5, 6. Out of 8, 2 3s are 6 and 2 4s are 8. Simple. Now let us see the last part of this question, which says probability of getting a number less than 9. So it is evident that all the numbers are less than 9 only. Okay, all the numbers are less than 9. So that means you will get an 8 out of 8, which is equals to 1, and it is a sure event, right? Okay, all the numbers are less than 9 only, so it will be compulsory to get a 1 here. Okay, now let us see the 13th question. 13th question says a die is thrown once, then what is the probability of getting a number which is prime? And the second part, a number lying between 2 and 6. Third part, probability of getting an odd number. Okay, so when you'll throw a dice, what are the total outcomes? 1, 2, 3, 4, 5 and 6, right? So the total outcomes are 1, 2, 3, 4, 5, 6. Now we need prime numbers. How many prime numbers are there? You can write it here, the favorable outcomes. Favorable outcomes. So is 1 a prime number? No, it is not a prime number, neither prime nor composite, right? Second, 2, is it a prime number? Yes. 3, yes, it's a prime number. 4, no. 5, yes, and 6, no. That means what are the total number of favorable outcome? We have to count the numbers. Okay, so there are 3 favorable outcomes out of the total 6, which is equals to 1 upon 2. Is it clear? Now see, what is the probability of getting a number lying between 2 and 6? So how many numbers are there which lies between 2 and 6? 3, 4 and 5 only. That means the favorable outcomes are, if you want you can mention the favorable outcome here. Favorable outcome is equals to 3, 4 and 5. So what will be the probability now? 3 upon 6, which is equals to 1 upon 2, right? And now let us see the third part, probability of getting an odd number. So first of all, let us write the favorable outcome here. Favorable outcome. 1 is odd, 3 is odd and 5 is odd. 1, 3, 5. So the probability would be 3 upon 6, which is equals to 1 upon 2. Okay, now let us see the 14th question, which is kind of important for your exams. Okay, let us see the 14th question, and this will be the last question of this video. We will see the rest questions in the next video. See, mark it as important. Okay. Now, one card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color. Okay, so total number of outcome for this question will be 52, right? If you haven't seen the introductory part regarding the cards, I suggest you to watch it by clicking it on the I button and then check it out. Okay, so total number of outcome is 52. In the first part, they need a king of red color. Probability of getting a king, I am writing like this, red king. Probability of getting a red king. So as you know that there are 4 types of cards in the pack, right? One is heart, diamond, club and spade. These 2 are black in color, right? And these 2 are red in color. Each set has 1 king. That means there are total 4 kings. 1 king, 1 king, 1 king and 1 king. There are total 4 kings in all. But here we are asked about red king. So there will be 2 red kings. There will be 2 red kings. So let us write the total number of favorable outcome will be 2. And what is the total number of outcome? 52. So this will be 1 upon 26. Simple. Now let us see the second part, which says a face card. Second, probability of getting a face card. Now how many face cards are there in the pack? It will be 12. Number of face cards are 12. What do you mean by face card? The cards having face. That means the king, queen and the jack. There will be 4 king in each of the sets. That means 1 in each set. And 4 queen and 4 jack. That means there are 12 face cards. So they are asking the face card only, not of the color. They are asking about the face card. That means there will be 12 face cards out of 52, or you can say that 2 6 are 12 and 2 26, 2 3s are and 2 13s. Okay, now let us see the third part, which says a red face card, probability of red face card. See, in these, out of these face cards, okay, out of 12 face cards, 2 kings will be of red color, okay, 2 kings will be of red color, and 2 queens will be of red color as well, and 2 jack will be of red color. So how many face cards are there which are red in color? It is 6 out of 52, right? 6 out of 52. So let us divide it. 2 3s are 6 and 2 26 are 52. Okay, so the probability is 3 upon 26. Now let us see the fourth part, probability of getting heart of jack, or you can say it's jack of hearts. Okay, jack of hearts, jack of hearts. So jack of heart, there will be one heart, okay, there will be one jack of heart, there will be one jack of heart. See, there will be one jack in the heart, in diamond, in club and in spade. So how many jack of hearts are there? There will be only one jack of hearts, that means 1 out of 52. Simple. Now let us see the fifth, probability of getting a spade. So how many spades are there? There are total 13 spades, right? So 13 upon 52, which is 1 upon 4. See, this question is not at all difficult. If you know what all cards are there in a pack and what are the characteristics, then it is very easier for you to solve this question. That is why I am again suggesting you to watch the introductory part of this chapter. Now let us see the sixth part, and which is the final part of this question, probability of getting a queen of diamonds. Queen of diamond. See, there will be one queen in each set, one queen in each set. So how many queens are there in diamonds? It is 1. So it is 1 upon 52. I hope the chapter is easier for you to understand. If you are having any query, you can ask us on the mail given here or in the comment section below. I'll see you in the next video with the rest of the questions, and the answer to the first question will be pinned in the next video. Till then, be safe and be happy and study with Ma'am and Me Academy.